Alrighty, so we're going to go over the kinematics unit here. Okay, start out with just here's some of the general concepts that are going to be focused on the final exam, and then I'll go into detail about kind of what those questions might look like. Okay, so what kind of things you'll want to look at in your worksheet package and things like that that could be useful to help you study for the kinematics portion of your final exam. A couple of reminders about the final exam. First off, that it is Friday, June 26th at 9 a.m. in the gym. Pretty important that you be there. Okay, other things, bring to the exam at least 2 pencils, at least 2, maybe 3, maybe 4. Bring a box, okay? Especially if you're a stressful person who breaks leads all the time, all right? Make sure you have stuff to write with, because if you only have 1 pencil and you break it, then you're waiting for one of us to come over and find out why your hand is up. And then when you tell us you need a pencil, then we have to walk over to the pencil box and get you a pencil and come back. And you lose time, okay? You don't want to lose time. So just make sure you have lots of those. Also remember that you need to bring your calculator and make sure that it has fresh batteries in it, okay? I really don't care when the last time you put new batteries in it was, put new batteries in it for the exam, right? Because when we come around to clear your calculator, if it tells us that there's a low battery, we can't clear it, okay? And so what I do is I put it in my pocket, and I walk around and I clear all the other calculators. Usually by then I have like 3 in my pocket, okay? And then I walk to the office. I don't run because I'm old and my knees are bad, okay? So I walk to the office and I put new batteries in your calculator. I clear it and I put your old crappy batteries back in, and then I walk back to the gym, which means you're without your calculator for a long time, and you don't want that on an exam where your calculator is necessary for like 95% of the questions. So okay, make sure you got fresh batteries in there so you avoid that source of stress for yourself. Okay, so pencils, calculator, really, that's it. That's what you need to bring, right? Now, if you want a bottle of water or something like that, that's fine. Just make sure it's in a resealable container, like not an open cup of coffee, for a couple of reasons. First off, that could spill. And secondly, sometimes the smells really bother other people, okay? So really keep that in mind when you're choosing your exam snack, if you are bringing an exam snack, okay? Advisable snacks for the exam would be things like granola bars or an apple, okay, or something like that. Okay, I've had people who come in with like an orange, which, that seems like a good idea. It's healthy, whatever, except that your fingers get all sticky. It's really, if it's a good orange, it really smells nice to me, but to other people, not so much. Okay, and then you have to go and wash your hands, right, in the middle of the exam. So just things like that. Keep that in mind when you're choosing that. It's not like you have to have a 5-course meal while you're writing your test, okay? Just bring in something to keep your blood sugar up. Granola bars, lots, okay? And it doesn't make too much noise, unlike a 500-gram bag of Doritos, which I've also seen. And that's really, really ignorant. People will want to kill you, and we might let them, okay? So yeah, don't bring in a 500-gram bag of Doritos. So just things like that to keep in mind, okay? Now, things you can't bring, right? You obviously heard the announcement this morning, okay? Put all your electronic devices in administrator's office / thieves paradise, okay? Like, honestly, guys, I would just leave it locked up in my car, right? Remember, you don't have a locker for the June exams, right? You'll have cleared out your lockers on the last day, so you don't have the option of leaving your phone and stuff in your locker. So I would leave it at home or leave it in your car. Leave it somewhere more secure than in an open pile where the first person who's done the exam gets free reign of everything in the office, okay? I mean, there's just some dishonest people out there, so I would just keep that in mind, okay? But you can't bring it with you to the test. It's really unfortunate if we catch people with their phone in the test, because then you get a 0 on the final and an incomplete in the course. So it costs you 5 credits. Hey, it's just not worth it. So please don't bring it in with you. It's really awkward for us and really unfortunate for you, okay, when that happens. All right, so those are the things you got to bring. All right, so kinematics. First thing we covered in kinematics was review of Science 10, okay, and that was scalar and vector kind of things. Okay, there's not going to be any questions that go, which of the following is a scalar quantity, because you got tested on that in Science 10, right? But you still need to know which things are scalar and which things are vector, because in the written response, if I give you a question and at the end it says calculate acceleration, you have to remember that acceleration is a vector quantity, so that you put a vector on it, solve it correctly, apply positives and negatives to things. Okay, so that's certainly something that's going to be important for you to remember, okay, which things are scalar and vector. We also went over speed is distance over time, and velocity is displacement over time. And remember that this is average velocity, average speed, and this is total distance, total time. Okay, if it's a multi-part question. All right, I don't foresee having a whole lot of v equals d over t for its own sake on the exam, certainly not in the written response portion. Okay, but there may be like a simple multiple choice question on v equals d over t, okay, something like that. But this is part of a lot of other questions. Okay, it's part of projectile motion. It could be part of an echo question in the waves unit. Okay, things like that. So it's certainly something that you need to be able to use. Okay, after scalars and vectors, we went on to graphing. Same graphs as we used in Science 10, right? So you're going to have position versus time and velocity versus time. Okay, expectation is that you can still use this. Y equals mx plus b. If you're given a line graph, it will have the equation on it, just like the ones you produced using Google Sheets for our labs. So they may ask you to extrapolate for something not on the graph. Okay, so make sure that you can still perform that operation. They may ask you to calculate things that don't involve using y equals mx plus b. Right, so remembering that for a velocity time graph, how do I calculate displacement? Okay, well, it's still average velocity times time, but that involves all those shapes and things like that that we had to do before. Certainly that kind of stuff could be on there. And you could be asked to interpret graphs. So in a multiple choice question, I might just throw a graph on there. It does, you're not asked to calculate anything, but it says, using the position versus time graph, on at right here, describe which statement best describes the motion that's going on. So it's a position time graph with a diagonal line going upwards, right? And the options might be A, acceleration, B, moving at a constant velocity, C, stopped, D, impossible to tell, I don't know, whatever. Okay, and you would have to pick the right one. So being able to interpret a graph just by looking at it, right? Those are the kind of things that would be tested with in terms of graphing. Right? Questions on graphing? After graphing, we talked about acceleration. Right? Do we have a lot of different acceleration formulas? What formula do I never use for an accelerating object? V equals d over t. Please don't. If you do, you won't get any marks. I promise. Okay, so no v equals d over t. But you do have a number of acceleration formulas. You don't have to memorize them. They're on the formula sheet for the final. Okay, and the formula sheet, incidentally, is exactly the same as the formula sheet you have already. It's just a fresh copy without all of your little scribbly notes on it. So you'll have all of those formulas. There may not be a lot of problem solving that's just an acceleration problem, but obviously acceleration is part of Newton's second law. Okay, it's part of projectile motion. So being able to use those formulas is important. Okay, so make sure that you are familiar with them. Maybe practice a few acceleration problems. Let's see how long it takes her to notice I'm looking at her. Oh, blocked out. Okay, that was a good joke. Hey, get in here. All right, so acceleration problems, are going to be not necessarily acceleration problems on their own, but acceleration as part of other problems. Make sure you can manipulate formulas on that. So that would be probably mostly in the written response part of the test, but there could be a simple acceleration calculation as a multiple choice question. In fact, you had one like that on your kinematics test. Okay? It was a simple acceleration question in the multiple choice. Okay, then the big one. Addition of vectors using vector component addition will most definitely be a written response item on your final exam. All right, so remembering things like drawing vector diagrams, tail, to head. Okay, finding X and Y components. Okay, then finding the results. Right, all of those things will certainly be important. So just as kind of a quick review on that, okay, I would have like vector 1 here. Let's say it's 100 meters long, 30 degrees north of east. It would have an X and a Y component, okay, and I would be adding that to a second vector that, let's say, goes like this, right? No, that's not really to scale, but you get the idea. Okay, X and Y, all right, I would have to find all the X's and all the Y's. In order to find my resultant. Okay, so this would represent my overall displacement, okay, and so on. So, okay, remember how those things kind of work, right? We've done lots of those, and in fact, this wasn't something that you guys really struggled with on your unit exam. In fact, that was one of the better questions on your kinematics unit exam, right? Is this also part of unit 2? Right? You may have to do this if you get forces that are in different directions. Okay? If you have forces that are in different directions, then you may have to also use vector component addition, except that the resultant then will be your net force, right? Because net force is the vector sum of all forces. All right, I would say spend some time on that. It's a 6-mark question. Okay, so you know it's a decent portion of your final exam mark. I want to say 86. I'm gonna have to double check. Okay, so vector component addition. Then after vector component addition, we did projectile motion. So what are we on here? 5. Okay, projectile motion tests everything in the first unit except graphing. The first question in the written response is a projectile motion question. You're welcome. Study your projectile motion. Okay. If you're shaking your head going, I don't remember that, really study your project. What's that? Oh, you hate it. Well, it isn't a tricky one. We only did about 25 like it. Okay. Yes, the whole test is in color. Okay. All right. So just keep that in mind, guys. You will definitely have a written response question, and there's a couple of multiple choice questions just about the principles of projectile motion. Okay, so make sure you just go over your notes. Okay, remembering things like, you know, the horizontal component travels at a constant velocity, whereas the vertical component is accelerated motion. Okay, things of that nature. So if we're looking at a projectile motion problem, okay, we have our projected velocity. So let's say that that projected velocity is, I don't know, 120 meters per second, and it's projected at a 35-degree angle. Okay. So the projectile is obviously going to do this. Okay, it's going to travel in that projectile arc and hit the ground somewhere over here. Okay. We'll be asked to calculate, or have always been asked to calculate, essentially the horizontal distance that it will travel and the maximum height that it will reach. Okay, whenever I gave you a question like this, that was the things I asked you to calculate. So that's probably what I'll ask for on the final. Now, our first step for projectile motions was, okay, that we break it up into vertical and horizontal parts. Okay, this is where it's important to remember that vertically, we are talking about accelerated motion, and that acceleration is always going to be gravity, but it has to be negative. because it's going to change directions. From a vertical perspective, all a projectile does is go up and down. Okay, from a horizontal perspective, all it does is travel at a constant velocity forwards. Okay, and then for the horizontal part, it travels at a constant velocity. Okay, so that'll be v equals d over t. We don't know which formula we're going to use vertically yet, okay, because we haven't calculated our information. Now, this initial triangle here, the horizontal side is the horizontal velocity, because this is a velocity triangle, right? The hypotenuse is the velocity. Okay, this side is the initial vertical velocity. Right? We have to remember that initial triangle, or it's hard to even get started. So, can I calculate what the initial velocity is with this triangle? Right? I have a side and an angle, which means I can find all the other sides. Okay, so VI is going to be the sine of 35 times 120 meters per second. All right, so that side's going to be 68.829, and obviously we want to keep all of our decimals. Meters per second. All right, if it's traveling all the way over and landing at the same height that it was fired from, what's VF? Same as VI, right? It's just going up and coming back down. Same distance up and down, same acceleration up and down. Speeds have got to be the same. All right, so VF is going to be negative 68.829 meters per second. All right, so that's what I know vertically. Horizontally, I can also calculate the horizontal velocity using this triangle. Okay, so V horizontal is going to be the adjacent side, so the cos of 35 times 120. All right, so that's 98.298 meters per second. What I'm being asked to find right now is the horizontal distance. What else do I need in order to get that? Kylie? Time. Okay, I need to have the time. Can I find the time with this vertical information? Right, do I have a formula that has A, the two V's, and T in it? Yeah, you've had it since Science 10. Okay, it's this one. All right, so I'm going to use that to find time. So that'll be VF minus VI over A. Okay, so that'll be our 68.829 minus 68.829. Okay, negative 68 divided by negative 9.81. Okay, and remember, it is important to keep all of our decimals for significant digits. All right, so this thing is going to be in the air for 14.032 seconds. Can I use this time over there on the horizontal part? Yeah, it's going to be traveling horizontally and vertically until it hits the ground, so their times are the same. Time is the one thing that they share. All right, so I take that number and I multiply it by the velocity I calculated earlier, okay, which was 98.298.24531. All right, so it's going to travel 1,379 meters, okay, which is pretty impressive. That's pretty far. It's over a kilometer. All right, we only have two significant figures here, right? So we're going to call that 1.4 times 10 to the 3 meters. Okay, they were basically all the same. There's very little I could do to change it that wouldn't involve you doing those same steps, just in a different order. Right. Now, the other thing you would often be asked to calculate would be the maximum height reached by the object. Right? There was one little thing you had to remember about where the maximum height occurred. Okay, how fast is the object moving vertically when it's at its maximum height? 0, right? That's where it changes direction and starts to come back down, right? So VF, instead of now being 68.829 meters per second, is now going to be 0. Okay, which now means that this formula is out. Okay, I can't use that one. It's not going to calculate the height. Height is a vertical distance. So I'm looking for D. Okay, I have A, VI, VF, and I'm looking for D. Okay, this would probably be my best bet for a formula. Definitely not V equals D over T. Sorry, I'm going to keep rubbing that in as often as I can. Okay. So we're looking for D here. So we're going to have VF squared minus VI squared over 2A equals D. We plug in our numbers there, 0 squared minus 68.829 squared divided by 19.62. Okay. All right, so it's going to reach a maximum height of 2.4 times 10 to the 2 meters. Okay. Is that ringing a bell for everybody? That's all right with that? Okay. I would definitely do some practice on projectile motion problems. All right, so graphing, okay, projectile motion, vector addition, okay, acceleration. I'm not saying the other stuff we did in that unit isn't important. I'm just saying it's quite minor by comparison in terms of marks. Okay, these are the things, these are the skills you're going to be asked to demonstrate for the kinematics unit on your final exam. Okay, now the final exam does generally go in order. Okay, so like in the multiple choice, you'll have questions on kinematics, then you'll have some questions on dynamics, then some on circles, and then some on waves. Okay, I'm not mixing them all up. It's good to get into kind of a groove on one thing and then move on to something else. The written response, because I have some questions that overlap units, okay, in the interest of keeping the test shorter, I made some questions that tested things from different units. It generally goes in order, but there may be some questions that incorporate things from 2 units, okay. So like a question on in dynamics that involves vector addition, okay, that's a crossover, right? It's got two things from 2 units in it. It could have something that has, to do with circles and periodic motion, okay, combine them together. So it might seem like it doesn't go in order, but it generally goes in order. Pardon me? A boat question. Oh, no, I know what you mean. I'm just debating how much detail do I give you? I've already given you quite a bit of detail. I told you there would be a vector addition question. I think that'll be enough. There's got to be some surprises, okay? I'm not the guy who's going to like be the guy who spoils it all. Okay. Yes, just written response, and it's just like a unit exam except longer. Okay, I'm not going to change the format on you now. That wouldn't be fair. So no, the format is exactly the same as you've written all along. Okay. The test is generally like in terms of like distribution between the units, pretty equal. Right? There's about the same number of marks for each unit. If there's one unit that got shortchanged a little bit, it's the last one. Okay, there may be a little bit less marks for simple harmonic motion and waves, but that's because you just wrote a test on simple harmonic motion and waves, and I already kind of know that that's fresh in your mind. I need to know about the stuff we did a while back, so there's a little bit more in kinematics, dynamics, and circles than there is on simple harmonic motion and waves. Okay. All right. Questions from you guys? What are some things that you want me to go over in terms of kinematics? I think I've gone over kind of the 2 big ones, but you want me to go over a boat question? I can go over a boat question. You still don't know for sure whether there's one on the test, but I'll go over a boat question. Okay. So here's our river, okay? We have a boat that's crossing the river, and the boat can move at, let's say, I don't know, 10 meters per second. All right, so the boat is aimed straight across the river and is moving at 10 meters per second. The river's current is 4 meters per second. All right, so because these are both vectors, we draw them tail to head. All right, so we've got the boat's velocity, we've got the current velocity. They are perpendicular to one another. All right, the question, if I gave you one, and when we did the ones in the kinematics unit on this, I would ask you things like, what's the resultant velocity relative to the shore? Or I would ask you, how far downstream will the boat end up when it reaches the other shore? Okay, so first off, let's calculate the resultant velocity. Okay, the resultant velocity with respect to the southern shore, we'll say. Okay, so that'd be this side. We're looking for that angle. So what I would do is, instead of using this triangle, I would just flip the triangle. And then I'd be sure to get the right angle. The sides are the same. Okay, it doesn't really matter which way I do it. Or I could calculate this angle and go 90 minus, it doesn't matter. Okay, so I'm going to calculate, first off, the hypotenuse. It's just, so 100 and the square root of 116. All right, so this side's 10.77. That's exactly the same as it was in your unit exam. How do I remember that? Because I made up the test. Okay, so that side's 10.77 meters per second, and then we got to find this angle here. So I'm going to use tan, and I'll just go tan to the minus 1 of 10 over 4. All right, so be 68 degrees. And that'll be from the southern shore, or it could be north of east. Either one of those directions would be valid, okay, as an answer for this one. Okay, we only have 2 significant figures, so it would be 11 meters per second at 68 degrees north of east. Okay, that would be the resultant velocity. Okay, the second part of the question on your unit exam was, how far downstream will the boat end up? Well, in order to do that, the question would have had to tell you how far across the river it is. So let's say it's, I don't know, let's say 200 meters across. Okay, I think on your test it was 10 kilometers, but we're just going to say it's 200 meters. Okay, so 200 meters across. How do I figure out how long it will take? Which one of those 3 velocities do I use? Connor? I use the 10. Okay, I can't use the 10.77 because that doesn't point across the river. This is across the river. The 200 meters is directly across. I can only use the velocity that points the same direction, right? So 200 meters over 10 meters per second. This is going to take 20 seconds. Everybody all right with that? Okay, so it takes us 20 seconds to get across. The entire time we're going across, we're also going downstream. Right, so if we're going downstream for 20 seconds at 4 meters per second, we're going to end up 80 meters downstream. Okay, so just V equals D over T calculations after that. All right, so in terms of vectors, that's an easy vector question because they're perpendicular. Okay, and then there's only V equals D over T calculations after that. So like mathematically, that's not a very difficult question. We just have to understand how it works. Okay. All right, what else? There may be some multiple choice questions on the variety that is not on the written. Yeah. Another projectile motion. Okay. Okay. One where there's less information. Sorry, I'm trying to make this one hard, really hard. So. Hmm. Okay, I think I've given you enough information to do that one. I'm trying to do it in my head right now, and I think I've given you enough information. What I want is the projected velocity with the angle. So I want this side of the triangle with the angle. Okay, so the question would say something like, a projectile is fired into the air at an unknown velocity and an unknown angle. It travels 400 meters horizontally and reaches a maximum height of 60 meters. Calculate the projected velocity. Yeah, you can do that one. Okay, your first step is you need to find this side. That's the first thing. That's the only thing you can find right off the bat, is that side, using the maximum height and other information associated with the maximum height. Okay, let's have a look at this one. So here's what we have to do. In order to get VI, we have to start with the information associated with the maximum height. Okay, at the maximum height, our final velocity is 0 meters per second. So it gives us an extra piece of information. Right? Now I can find VI, and I can find it using this formula. VF squared equals VI squared plus 2AD. All right, so I'm going to manipulate it for VI, which means it'll be VI equals the square root of VF squared minus 2AD. Right, so when I plug in my numbers there, okay, I'm going to have 0 squared minus 2 times negative 9.81 times 60. And when I do that, I find that my initial vertical velocity is 34.31 meters per second. There's some decimals on that, but that's essentially what it came out to. All right, so that's VI. Now, for the whole trip, that's also VF. Okay, so by calculating that, I gave myself what VF vertical is when the ball strikes the ground over there, whatever this thing is, that's projectile. Okay, so now I know VI and I know VF is negative 34.31. Since I have those two numbers, I can now calculate the time that it is in the air, which I need because, guys, if I'm going to get this number and this angle, I need this side and I need this side. So I need to find the horizontal velocity. For that, I need time. Okay, so the time is going to be negative 34.31 minus 34.31, initial minus final, over negative 9.81. And that tells us that the time is 6.99 seconds. Okay, so now we know the time. Now we can go over and use our horizontal information. The only piece of horizontal information we were given was how far it traveled horizontally. And now we know how long it took to go 400 meters. So we can find the other side of our triangle that we need. 400 over 6.99 gives us 57.18 meters per second. Okay, so now I have this side is 34.31 meters per second. I have this side is 57.18 meters per second. Now I can find the magnitude and direction of the projected velocity. All right, so I'm going to do a Pythagorean theorem calculation. Okay, so the projected velocity will be the square root of 34.31 squared plus 51.18. Was it 51? 57.18, right? Squared, okay, and that will give me 66.7. Actually, I think I only have two significant figures, so it's 67, okay, meters per second. Now I have to find the angle, which I'm going to use those same two numbers for. 10 to the minus 1, because it's opposite sorry, opposite is the 34, okay, is the vertical part. 34.31 over adjacent, 57.18. And when we do that, we get 31 degrees. Okay. So our projected velocity is 67 meters per second at 31 degrees above the horizontal. Okay. So still essentially the same steps, just in a different order. Okay. We used all the same formulas. We used A equals VF minus VI over T. We used VF squared equals VI squared plus 2AD, and we used V equals D over T. We just did them in a different order. All right. A projectile motion question could go in any order, but it's always the same steps. Okay. All right, what else? That one took a little longer than I thought it would. Okay, well, hopefully some other questions will come up. What you have to work on right now, okay, is that I posted the final exam review package on Google Classroom yesterday, or maybe even the day before. Why does it keep doing that? Okay, so there's a few things for Unit 1, and we already went over these. The key concepts were scalar and vector quantities, vector addition, okay, acceleration, graphing, being able to do projectile motion and vector addition problems. Okay, there's some stuff in your textbook that, the online textbook, if you want to look at that, or there's the questions I have down here. Right. So for Unit 1, there's 5 problems there. These were all at some point on a final exam. Okay, so they give you some idea of the kind of things that I might ask on this final. So they are all things we've done in class a bunch of times. So you can look at those. Okay. Suggestions for things to do. Okay. You have a ton of worksheets in your digital workbook. Don't do them all over again. You don't have time for that. Okay. But maybe pick a question or two off of each one, especially ones that maybe you struggled with before. Okay. If you can do them now, great. You're good. Okay. If you can't, then work on them. Come in and see me for help. Ask some questions. Okay. Things like that. So you've got lots of resources for extra problems to use for preparation for your exam. And guys, with physics, the best way to study is to do practice questions, right? Reading over your notes is not as effective for physics as it is for like biology, right? Because there's not that many multiple choice questions. I think there's 20, okay, multiple choice questions on your final exam. It's mostly problem solving. So 66 marks, yeah, okay, on the written response, okay? Because that's where I can test all of the skills. I'm worried about the skills, okay? I mean, yes, there's some multiple choice questions that check your understanding, but checking your understanding is, for me, show me that you can still do this stuff and you understand it at a good level so that when you go to Physics 30 and things get really abstract, that you can think outside the box a little bit, okay? Because that's what's going to be important at that level. Okay, so make sure you're doing practice problems of these types, okay? You know what kind of problems I'm going to ask, so make sure you go over those kinds of problems from your digital workbook and from the review package, okay? All right, so you got some time here still. I would say get looking at that stuff, and if questions come up, just ask. That's what I'm here for. Okay, so ask lots of questions and you get more out of it. Okay, so we have a quick request here for a law of conservation of energy question from the simple harmonic motion and waves unit. So let's say we'll have a mass on a spring. Okay, and the mass will be, I don't know, let's say 0.75 kilograms. Okay. It is oscillating with simple harmonic motion. Okay. Okay, so this would be a pretty average type of law of conservation of energy question to do with a mass on a spring. Okay, so we know the mass is 0.75 kilograms. We know the maximum amplitude is 33 centimeters. Okay, we are looking for how fast the object, the mass, is going when it's only 10 centimeters from equilibrium. All right, so we'll start out with, obviously it's a law of conservation of energy question, so EI equals EF. All right, and that's going to mean that 1/2 kx initial squared plus 1/2 mv initial squared equals 1/2 kx final squared plus 1/2 mv final squared. Okay, at the maximum amplitude, what kind of energy does the mass have? Potential, potential only, because at its maximum amplitude, that's where it's changing direction, right? So initially, there's no kinetic energy, so we can simplify a little bit. We are trying to find the speed of the object at the 10 centimeter mark, okay? So it has both kinds of energy at that second position. Everybody okay with that? All right, so I'm manipulating to find VF, okay, get it by itself, right? There's a half in every single term, so I'm going to cancel those off right away, right? And I'm going to have that kx initial squared equals kx final squared plus mv final squared. All right, then I'm going to bring kxf over to this side by subtracting. Okay, and I'm looking for VF, so I'm going to divide both sides by m, and then I'm going to square root. That will get me VF. With me so far? All right, now I'm going to plug in my numbers. Okay, so we said that K was 16 newtons per meter, okay, times the initial, which was the maximum amplitude of 0.33 meters squared, minus 16 times 0.1 meters squared, divided by, we said the mass was 0.75, right? All right, so if we do that, that should give us our final speed. So all right, so we're looking at, we'd have a speed of 1.5 meters per second at that point. Okay, make sense? They wouldn't get much different or tougher than that. Okay, any other ones, guys? Okay, so obviously tomorrow is your wave exam. Okay, make sure that you are, sorry, simple harmonic motion and waves exam. So make sure that you are ready for that. Okay, if you want to come in a little bit early, I will let you start a little bit early. Let's say, well, I should be able to be here for 20 after, right? We'll do my best anyway.